All right, so from here, let's move into the uniform probability distribution. So we're going from that discrete data to continuous data. Number 6 says the time it takes for a professor to commute from Thomasville to Tallahassee is uniformly distributed such that the variable x is capital U for uniform, 4365. So the minimum value is 43. The maximum value is 65. I want to find the mean and the standard deviation of this distribution, and we'll round to one place for ease, and we'll talk about what these mean. So for the uniform distribution, you'll have these formulas as well, but your mean, your mu, is A plus B divided by 2. Here. Mu A plus B over 2. Where A is your lower value, so that's 43. B is your upper value, that's 65. Divide that by 2. So here, 43 plus 65 is 108. Divide that 108 by 2, and I get 54. So the average commute time for this professor is 54 minutes. Your standard deviation formula is the square root of b minus a squared, all divided by a constant of 12. So we're looking at b of 65 minus an a of 43, that's squared, all divided by 12. Well, 65 minus 43, that's 22. So I'm looking at the square root of 22 squared divided by 12, all underneath my square root. So again, 65 minus 43, that's 22. I'm squaring it, dividing by 12. Square root of all this gives me 6.4. So my average commute time is 54 minutes. But this isn't a guarantee. It's not going to take me 54 minutes every day. It varies some from day to day depending on traffic and other things going on in Tallahassee with roadways. So this can vary by as much as 6.4 minutes. So typically varies by 6.4 minutes. On number 7 and 8, we get to some probabilities. Number 7, same scenario. What is the probability it takes him 60 minutes or more to commute? So this is where I would encourage you to draw out your schedule. So uniform, it's that rectangular distribution. My lower bound is 43. My upper bound is 65. I'm looking at 60 minutes or more. So this section of the curve. The key for probability here is that it's equal to the area. You have a rectangle which has an area of base times height. Your base in this case is a length of 5. From 60 to 65 minutes, that's a gap of 5 minutes. You could just say 65 minus 60. Your height has a formula, which will also be given to you for the test. It's 1 over b minus a. So we're looking at 1 over 65 minus 43. It's 1 over 22. So 5 times 1 over 22 will give me my area of my rectangle, which will give me the probability of 60 and above, or 60 to 65. So I'm going to say this is the same thing as 5 divided by 22. I'll get 0.2773 if I take that to 4 decimal places. Same idea in number 8. It's a rectangular distribution going from 43 to 65. We want probably between 45 and 55 minutes. So here is 45. Here is 55. We're looking in between there. Once again, another rectangle, which has an area of base times height. This time the base, this is a 10-minute gap from 45 to 55. You could just subtract those two. Height is still the same. It's 1/22. So we're looking at 10 divided by 22, which gives me 0.4545. And final uniform distribution question, same scenario. What percentage of the curve is more than 1 standard deviation from the mean? So think about my distribution. It's the rectangular one from 43 to 65. We're looking at more than 1 standard deviation from the mean. So my mean right in the middle is 54. That's the center of my distribution. I know that from number 6. My standard deviation from number 6 is also 6.4. So going 1 standard deviation from the mean, I'm going to go up 6.4. So that would be to 60.4. Just 54 plus a standard deviation of 6.4. So I want to go more than that. So I'm looking at this area. But it just says more than 1 standard deviation for the mean. It doesn't say more than 1 standard deviation above the mean. It just says from the mean. So it could be above the mean or it could be below the mean. So I could take 54 down 6.4. Looking at 47.6 here in this section. And so now I've got 2 rectangles to find the area of and combine. So this area, base times height, its base from 60.4 to 65. So I could say 65 minus 60.4 gives me a base of 4.6. Height is a continuous 1 over 22. So 4.6 divided by 22 gives me 0.2091. And maybe you see this already, but on this lower side, if I subtract these two to see what this base is, 47.6 minus 43, this also has a base of 4.6 and a height of 1 over 22. So I'm going to get the exact same thing again. So my answer is just 0.2091 times 2. So 0.2091 times 2. And I get 0.4182. So in this uniform distribution, about 42% of the times are more than 1 standard deviation from the mean, either above or below. So that one was kind of tricky. You will see one sort of like this on the test, so do pay close attention. I've got my mean in the middle. Using my work from number 6, I went up by a standard deviation, down by a standard deviation because it just says more than 1 standard deviation from the mean. It could be above or below when it says from the mean. And then found the base times height of both of these, which are the same. So I'm running out of time, so we'll stop this one and move to the normal distribution.